Okay, I want to try to go through these next couple of ones quickly so that we can get back to looking at life in lecture on Thursday and debrief the simulation we did last Thursday. There are a couple of topics dealing with the potential for actual liquid water to be around and available on Mars today. Both of these topics basically are looking at what is going on with water today. And we're interested in, is there any liquid water available? And what do we know about the ice, the water ice on Mars? Because we can always use water ice for a source of water. There are two topics related to liquid water. This idea of gullies, which is a little bit less in the research focus today, and these recurring slope lineae, which are indicated by what's going on with this figure here. Okay. Gullies were a very hot topic about a decade ago, and I want to take a look quickly at them first. And there's not a lot that I want to say yet about these RSLs, but they're probably the most promising and hottest area for whether or not there might be pockets of liquid water near the surface on Mars. Okay, so the topic of gullies is basically about 15 years old now, and was really made possible by the better cameras that we put into orbit around Mars with the Mars Global Surveyor. Okay, so if you think of Mariners and Viking as being Mars spacecraft exploration 1.0, then we had a big break after being so disappointed with the Viking results, and then we went back to Mars starting about 1996 with a whole armada of probes, and have been investigating Mars ever since. Mars Global Surveyor was part of the kickoff of Mars Robotic Exploration 2.0, and with that came better cameras in orbit, better probes on the surface, and it was the better cameras in orbit in particular that led to this interest in gullies. So, with the higher resolution cameras in orbit, people started seeing these structures on the sides of hillsides, craters, slopes, crater sides, slopes, and so forth, where there appear to be these source alcoves high on the sides of these slopes, with some channel cutting down the slope, and then with the material kind of leading to a debris apron at the bottom. And with all of these high-resolution images, all of a sudden, these researchers were seeing hundreds, thousands of these structures around Mars. So here's something that we observe. What's our next step? Well, next step would be to say, well, how do these form? So before I go on, what would be some of the ways you might think that these would form? Okay, well, rain would not lead to this kind of structure at the top of the channel. Rain could carve a channel and with a kind of a debris apron at the bottom, but it's not going to necessarily generate this alcove kind of structure at the top. And we know that there is no rainfall on Mars today. Jeffrey?
I want to say meltwater.
Could be meltwater. Okay, so meltwater might be coming from somewhere. We don't, there could, well, we'll go into that in more detail, but water could be melting, flowing down the slope, What?
This is my topic, so I know.
Okay. It could be a variety of things, but the interest was generated because, these clearly look like young structures. They're not obliterated by craters. It is relatively recent erosional process that's going on Mars today, and there are only a handful of things that could lead to that erosion. It's not lava running down and carving this channel out. It could be water, it could be wind, it could be just dry deposits of sand falling down. Yeah?
What's the scale of this that we're looking at?
Oh, good question. This would be hundreds of meters, but not kilometers.
So there's like a lot of water.
Well, there's a lot of something going on. And if you want to interpret this figure a little bit, we basically have a high mesa here, and this is the crater slope, and all along the crater are these channels, these gullies that, like I say, look to be fairly recent erosional events that are depositing material at the bottom of the slope. Yeah, this is just another figure showing typical morphology. See, fairly well-defined gullies along this edge here. Maybe in here, it's hard to tell with the shadowing what's going on over here. There's other areas where the gullies don't seem to be as prominent. But again, this alcove channel and fan kind of morphology. They have a very interesting distribution. You don't find them at the equator, and you don't really find them much at the poles. You find them at relatively high latitudes, but in this kind of band. So the white dots are examples of where they have found these gullies. Okay.
That's like, even on Earth, that's like where most habitable stuff exists.
What do you mean?
Like, these areas, right? Like, this on Earth would be like tropic Cancer, tropic Capricorn.
Let's see.
Seems like these kinds of.
Well, they're clearly occurring at mid-latitudes. Now, on the Earth, clearly the tropics are pretty habitable, so I'm not sure exactly what you mean by the mid-latitudes being areas of where...
It just seems like wherever things are in Mars are always in these areas, like mid-latitude places.
Yeah.
The other charts we see.
Yeah, but it does bring up the question, what kind of processes could be going on to create gullies at these latitudes that would not be happening at the equator, would not be happening at higher latitudes? So that's a clue, clearly. Noelani.
I think that's because Mars has such extreme variations, like in areas. Like, if it's hot somewhere, it's really hot. If it's cold somewhere, it's really cold. That's why in the middle areas, it's where it's evened out.
It could be, yeah. But whatever it is, we need to look at something, a reasonable mechanism that would be geographically restricted, and with some explanation for why. I mean, if these are related to water, why aren't they occurring where it's warmer at the equator? Why? So those are the things we have to address. The other thing that is kind of unusual is that if you look at the bulk of these, as we saw in the previous figure, the bulk of these gullies are at these mid-latitude areas. But in those mid-latitude areas where they are most prominent, you primarily find them on slopes that are pointed away from the equator and toward the poles. So that's another very distinct aspect of their distribution that would need to be explained by by whatever mechanism we come up with. If you go further away from the equator to some higher latitude regions, we've got more of a mix. But again, it's in these areas where the bulk of the gullies are, and in those areas they are primarily facing away from the equator toward the pole. So they would be on north-facing slopes in the northern hemisphere, and they'd be on south-facing slopes in the southern hemisphere. Just gloss over that. Okay, so people have come up with alternative explanations. What the explanation that was most exciting to people would be, let's say that this is a north-facing slope in a northern hemisphere gully. What the original researchers and a number of other researchers proposed was that we would expect there to be a layer of groundwater at a certain depth below the surface of Mars, where it's warm enough for the ice to melt, and there's enough pressure underground to keep that water liquid. But what happens when that water flows along, a particular layer of sediment, is that it'll eventually hit this this edge of the crater. And we can assume that that water table would also be on the other side. Okay. So if the sun is in the south, and this is a north-facing slope, and this is a south-facing slope, what's going to happen to the water on the south-facing slope when it hits that edge of the slope? It's going to evaporate. This slope is going to be warmer. As the water hits that edge, it's going to experience the low atmospheric pressure of Mars. It's going to, the sunlight will be beating down on it, and it will just evaporate. And so any water that's coming out here is just going to evaporate into the atmosphere. But what's going to happen on the north-facing slope when this water hits the edge of the crater? What? Not right away. What's the temperature of this north-facing slope going to be? Extremely cold. So liquid water, when it hits this extremely cold area, is going to do what? It's going to freeze. And so the idea would be that you would build up an ice dam here where this liquid water is coming into this colder area. What happens when that ice dam eventually fails is that we get a torrent of water quickly running down, cutting out that channel, and then rapidly evaporating and going away. Okay, so here's a mechanism. It's a plausible mechanism. It explains the distribution. We would not expect to see these gullies at the equator because the slopes at the equator are not cold enough to create these ice dams. Therefore, we're never getting an accumulation of water behind the ice dam to burst out and run down. Instead, we get a gradual evaporation of water as it comes to the side of the hill, and that's why we see them at mid-latitude regions facing away from the poles. So this is a very nice, tidy proposed mechanism. It fits the data. There are other explanations as well, though, but I think I may just mention them. One of the other big researchers in this area suggested that in what's going on is that these pole, that's crappy. That the pole-facing slopes are going to be the areas where ice deposits or snowpacks build up during those times when Mars is experiencing more glacial kinds of conditions. And with the snowpack on the pole-facing slope, water can melt. You can get melt water from underneath the snowpack that can run down the slope and cut the channel. And then currently under Mars current conditions, those ice packs, those snowpacks are no longer stable, and so they are gone. And what it does is it leaves this channel behind as an artifact of, what conditions were like, 50,000 years ago or 1,000,000 years ago when the climate was different and these snowpacks were developing. We've got some reason why that explanation is probably not the case that I'll show in just a minute on the next slide. So there's still some interest in this, but more and more as people have looked, or there's still an ongoing controversy as people look at these high-resolution photos, whether these gullies are actually carved by flowing water. Maybe it's just dry wastage of the sand rushing down the hillside that is causing this. So no water involved at all. I think this and this are probably the most the explanations that are most still in the running for explaining these features. We cannot send rovers to these places yet because they're at this point still not rover friendly. One thing that has kind of refuted the ancient snowpack hypothesis is that we can actually see gully activity over the course of a few years. So the nice thing about having Mars Global Surveyor in orbit for about 10 years or so is that it could take pictures of the same area over and over and over again. And so here is a picture that was taken in 2001 of this crater. And then when Mars Global Surveyor took a picture 3.5 years later, there's new gully activity without any snowpack, being involved here. So it's this kind of recent activity that, first of all, got people very excited about the gullies because, hey, something actually is occurring on a human timescale here on Mars. And also provided evidence that it's not just a remnant of past glacial kinds of activities. Until we get people or rovers there to actually drill down, see is there an ice dam, is there water, is this just a dry sand falling down, it's going to be maybe difficult to resolve some of these hypotheses. What's of more interest more lately, is this idea of these recurring slope lineae. Lineae just means a linear structure. These show up on various slopes around Mars, and they're recurring, meaning that these dark streaks show up, they disappear, then they show up again in the same area, and then they disappear. And they tend to do this seasonally. So What's very interesting and exciting about these RSLs is that they tend to show up in the Martian spring in the area. They develop, and then they disappear over time, only to show up again next spring in those areas. So if you're looking at this, what might be causing these dark streaks to show up in the sediments that are on these slopes? Somebody going around and spray painting, and then probably. I mean, you can't expect wind-blown dust to create these patterns, right?
It looks like they're kind of coming off the shape of there seems to be like erosion patterns on the rock, and the lines in the sand kind of continue off of those, so it looks like.
Like in here, there's this constricted channel here, and then we've got these slopes.
Like miniature valley networks.
Yeah.
I mean, yeah, so it looks like something's flowing down.
Looks like something is flowing down from these areas. We know that liquid water is not stable on the surface, but what other kind of water could be causing these dark streaks? If it's not surface water, it could be groundwater. Okay, so maybe there's water just flowing underneath the surface from these higher upper slope areas and wetting the surface sediments from below as this water flows downhill. I mean, clearly that's why people are excited about these structures, because they could represent pockets of groundwater just below the surface that that could be available for microbes and could be available for us. These have a different distribution than the gullies, and as I said, they do develop seasonally. So there's the interest in whether this could be water. What is of particular interest is that people are recognizing more and more that highly salty water called brines could actually be stable in the current conditions we have on Mars. The more salt that is in water, the lower its melting temperature, and the more resistant it is to evaporation. And Curiosity recently, made some news with some investigations it did on the ability of soils in the area that it is investigating to create these kinds of brines. The soils have a lot of salts in them, in particular these perchlorates that we'll come back to time and time again. And the presence of these salts could actually provide an environment where liquid water could be stable just right underneath the surface of the planet. And so the idea with these recurring slope lineae is that what we are seeing is essentially subsurface, but just very subsurface brines flowing beneath the surface of these slopes, wetting the slopes from underneath, resulting in the dark patches that seem to flow down the hill. And then as summer proceeds, those brines eventually evaporate away, and the dark slope streaks somewhat go away over time, but then they're replaced again next spring as enough water melts to create these brines that flow downhill again.